Thanks very much, Francis. I'm very excited to be here. I have the great privilege of showing you some of the things that Stantec, some of the products that Stantec is actually developing to deal with some of these climate change impacts, particularly the cascading events. You know, for the last couple of decades, we had this funny conversation around the world where we were not even sure if climate change was real, and certainly it's been worse in geological past, and maybe our contribution to it wasn't so, we were arguing about what our contribution was. And that really left out this important idea that one of the things that's changed since geological past is we're here, and climate change is affecting the environment on which we rely. It is affecting the structures that we use to transport ideas and goods and services and energy. And perhaps most importantly, it's affecting life. We're losing life in the process. So Stantec is building a suite of tools to deal with some of these problems. Now, I'm only going to have time to talk to you today about two of those tools. One of them is a tool we call Storm, and I appreciate the long setup that Francis and Dave gave me by saying, hey, rainfall is a really important thing. So what Storm does is Storm basically it's a low-cost digital solution that takes high-resolution rainfall data and turns it into some derivative products that help us solve problems. And we know rainfall causes problems, right? We've heard floods are the obvious one, but it's also scour around watercourse crossings that expose infrastructure like pipelines. And very obviously as well, perhaps, it's landslides. One of the things that you may not realize, our traditional way of gathering information around storms, for instance, is that we would put in physical instrumentation. But that physical instrumentation, it's not a really dense network. In Canada, for example, on average, we've got one physical station about every 5,000 square kilometers. So you can imagine if we have one here at this orange dot. This is the November atmospheric river event that occurred last year. We might not be representing the whole picture at that station. So this needs a solution. Now, the other product we're going to talk about today is something called DebrisFlow Predictor. So one of the cascading events of a driving thing like rainfall are debris flows, and we know a lot about them. They are perhaps in some ways the epitome of a cascading climate event that affects humans. So imagine we've got a warming climate, and we have more intense, more frequent rainstorms, and we have more intense, more frequent fires. And in this domino-like effect, this cascading effect, we then produce debris flows. And debris flows are particularly terrifying because where they start isn't where they end up. And so they go and affect communities a long ways away from the source. So let's go and talk a little bit about Storm for a second. So I mentioned that we had this dispersed physical climate gathering system, right? Where we physically installed stations. And so we need a better solution, and installing thousands more stations isn't a great solution, but we can turn to space. And so we do that, and we look at radar that's moving across, that's gathering rainfall data that's moving across the country. And we can get data using something like the HRDPS system. That's the High Resolution Deterministic Predictive System. It's available to all of us from Environment Canada. We have similar solutions in other countries. And we can pull dozens of variables: ground moisture, rainfall, wind speed, temperature. And we can actually watch it as it moves across the continent. And so that enables us not only to know what's happening right now, but to know what's going to happen in a few hours, maybe a couple of days out. The resolution is something like 2,000 times better resolution. What does that look like? Well, what if we put a station every 2.5 square kilometers? Highly precise, highly discretized information that we can then pull together and gather to produce aggregate products. So this is important. Storm isn't just us watching radar. It's us turning that radar into something useful. So one of our speakers yesterday, Mark Bartlett, he's on the frontiers of rainfall runoff models, developing new things, publishing that work. And so Storm has built into it a rainfall runoff model that he's designed. And it allows us to take, for a watershed that you care about, a location that you need to know the information, it allows us to gather all the rainfall that's dropping into that area, flowing to that point, and tell you what the rainfall generated discharge is at that location. But not just once, every hour, all the time, while you're awake, while you're sleeping, while you're going to work, and so on. Another storm module looks at the landslide hazard and says, all right, what if we could take all of that data for a location that you care about, again, and we will work with the 1 hour rainfall all the way up to the 30-day rainfall, and if any of those intervals exceeds known landslide triggering thresholds, we're going to let you know. It's going to work in the background when you're busy doing something else, and it's going to send you an email or a text if that problem is, or if that threshold is going to be triggered, if you have to worry about your assets, if you have to worry about human safety. Storm is its own product. It actually it solves a whole host of problems. And DebrisFlow Predictor solves a whole host of problems, but they also work synergistically together. So DebrisFlows, really what we care about with DebrisFlows is three things. We care about where they're going to occur, when they're going to occur, and where they're going to go. Well, the good news is where they're going to occur, we have a really good understanding of. So this map shows the USGS post-wildfire debris flow potential. Now, that's pretty specific. And they're saying that these, by colors, red being the worst, this is the likelihood that you're going to have a debris flow in your watershed if you get a storm of 24 millimeters in 15 minutes in Colorado. And by the way, in Colorado, that happens every year. What they don't know, what we haven't been able to unravel up till now, is how far that debris flow is going to go and how bad that damage is going to be. So it's sort of this ambiguous warning that says there's a bear in the woods, but don't worry, we can't tell you more. So Stantec has fundamentally changed that with DebrisFlow Predictor. So for the first time, we are able to, at a regional level, computationally efficiently, we are able to have our experts go through and tell you exactly where those debris flows are going to go, how far they're going to travel, how deep they're going to be, how much scour is going to go along the way, and it's probabilistic. We have deployed it across, I think at this point we've deployed hundreds of thousands of simulations since 2019 when we first came out with this. We've deployed it in Indonesia, which is this example here, and you can see just visually how well the middle version of the model looks compared to actual debris flows in 2016 and 2020. We've deployed it in Italy, in Colombia, in Switzerland, in Canada, in the US. And because it's probabilistic, we can do hundreds or thousands of runs. And so now for an asset that you care about, a road, a house, facility, some kind of structure, we can tell you the likelihood, the actual likelihood that will be impacted by a debris flow, and because of the depths of the scour and the deposition that we're able to ascertain, we can tell you what that damage is going to be like and how to maintain it or how to mitigate it. In July 20th, 2021, in Black Hollow in Colorado, a debris flow killed 4 people and destroyed 5 homes. We were working in adjacent watersheds with DebrisFlow Predictor for exactly this kind of process. And we immediately took those same parameters and applied them to Black Hollow, and we were able to predict this debris flow almost exactly. It actually was the subject of a couple publications that came out afterwards. Now I want you to think about that. Had we been allowed to deploy DebrisFlow Predictor ahead of time here, we could have told them what that was likely to be, what the debris flow would likely to be, who would be damaged, how it would be damaged. And if we could have deployed Storm, we could have told them when it was going to occur. So we could have saved lives. But we're just beginning. It's only been out since 2019, and right now we are currently working in Colorado for a whole bunch of post-wildfire debris flows. We're doing work in California, communities in BC, and elsewhere in the world. And not just for communities, but our industrial clients are also bringing us in to say, hey, we need to protect our assets. We need to understand what the potential damage is. We need to make sure that we're moving energy safely and that we're getting things to clients. Stantec has developed a whole host of great solutions, and we're going to hear some more today. We're incredibly proud of them. We hope that you'll reach out to us internally, externally, and let us know what your problems are and let us help solve them. I'm happy to take questions.